Hi everyone, this is the second video for week 5. We're going to start by talking about this very special number called E. You've probably seen it before in 135 or 103 and all. There are a number of ways of getting to this number and trying to find out what it equals and what it means. The simplest one is to consider this expression. Now, why is this expression interesting? It's because as n increases, 1 divided by n becomes smaller and smaller. Right, so this number gets becoming smaller. But then you raise it to a power, right? So there's one factor which is making this smaller and one factor which is making it bigger. So the question is, does it go to 0? Does this factor win and you become 0, or does this factor win and you become infinity? So let's try to see what happens. So let's plug in different values. Let's start with the simplest, n equals 1. So 1 plus 1 over 1 is 2 to the power 1, which gives me 2. Then I get 1 plus 1 half. So this is what I mean. Initially, the thing inside the bracket was 2, and the power was 1. The next, 1 plus 1 half is 1.5. So it becomes smaller, but the power is bigger. And this comes out to 2.25. And then, again, it becomes smaller. It's 1.33 to the power 3, which I'm going to need a calculator. 1.33 to the power 3 is 2.35. So far it's increasing, right? 1 plus 1/4 is 1.25 to the power 4. So I hope this makes sense what I was saying, that as n increases, this number in the parentheses becomes smaller, but the power increases. So the question it's really interesting to ask which one wins. 2.44. So it looks like it's increasing, right? It increased by 0.25 here, and then increased by 0.1, then increased by 0.09, 1.2 to the power 5, 2.4, let's make it 4.9. Now it's increasing, but one thing to notice is it's not increasing as much as it was doing in the beginning. Yeah, here the increase was 0.25, here 0.1, and then 0.9, and now we are down to 0.5. This is 1.66 to the power 6. That's not true. 1.16, right? 1.16 is, yeah. 1.16 to the power 6 is 2.436, or 2. Is that right? Maybe my value for 1.6 is not correct. Let's just do 1 plus 1 divided by 6. 1.67, I guess, then. To the power 6 is 2.52. Okay, now we're only increasing 0.03. So now let's make a bigger jump. Let's go to 50. So let's go 1 plus 1 over 50, which is 1.02, and raise that to the power 50. I get 2.69. So it's still increasing, right? But now see, in going from 6 to 50, the increase itself was really 0.252 to 0.269, which is not a lot. Let's go higher. 1 plus 1 over 100, raise that to 100, 2.7. Now it's interesting. I almost doubled this number, and this increase is so tiny. 1 plus 1 divided by 1000 to the power 1000, 2.7, that's roughly 2.72. So now I increased this 10 times, and this only increased like ever so slightly. So essentially what is happening is, even if I take a big number, let's say I do 100,000. Let's see if this calculator can. 100,000, 2.718. Right, so 1 plus 1 over 100,000 to the power 100,000. So eventually what's going to happen is this number, if you keep on increasing n, none of the two situations happen. Namely, it doesn't become 0 and it doesn't become infinity. It goes to this unending number, which is called e. And just like pi, it's irrational, non-repeating number. So the mathematical way of saying that is that as n, this arrow meaning goes to infinity, the value gets closer and closer to a constant, which is 2.718, and infinitely many numbers or digits, and that's called e. It's an irrational number, just like pi. And because the definition of e comes with an exponent, it's a very natural occurring base for an exponential function. So remember, exponential function, the base b is any number that's positive and not 1. Now e is 2.718, so it's fine. E to the power x is defined. And because of the very natural way in which it is defined and it occurs around us, it appears in a lot of formulas and a lot of models that we use. So here an infectious disease is modeled as this particular equation, and this gives the number of infected people at time t. So first question says how many infected people at time t equals 0. So that means I'm plugging in 0 for t. So I have 10,000 over 5 plus 1245 e to the 0. Now this is an exponential function, and any number to the power 0, even if they are fractions or decimals, is 1. So this is just 10,000 over 1250. I think that should be 8. Let me verify. Yeah, this comes out to 8. So at time 0, there are 8 infected people. Then it says find V1, V2, V3. I'll just show you V1 and V3. So it's going to be 10,000, 5 plus 1245 e to the power negative 0.97. And you just use your calculator, because you see there's an e button. Where is it? Right here, where it says ln. Above that is e to the x. So let's find that out. Oh, clear everything. So I have 10,000 divided by, I put a parenthesis, 5 plus 1245 times, I go second ln to get e to the power negative 0.97, and I close both the parentheses, 20.97. So pretty infectious disease, yeah. In one day you went from 8 infected people to 21 infected people. The same thing for 3, 1245 e to the negative 0.97 times 3 now. So let's see what that is. 10,000 divided by 5 plus 1245 times e to the power negative 0.97 times 3, 137. That's crazy. So by day 3 you already have 137 infected people, which most epidemic models they use E as a factor of spreading of infections, so it's not very surprising. The last part, slightly tricky. Graph the function and describe the behavior. So for graphing this function, we can kind of do it analytically. Here's how. Now t is the time, so we're just concerned with positive values, right? And we already saw that at 0, it's about 8. So 0, 8 is in there. What's happening? We know it's increasing, right? So let's look at that. Now this value, because of this negative, this is going to be smaller and smaller and smaller and smaller, right? And this makes it smaller, this makes the denominator smaller, and that makes it, the whole thing, larger. So as t goes to infinity, what happens to e to the negative t? So think about it. E to the negative t is 1 over e to the t. So as t increases, e to the t increases, so 1 over e to the t decreases. So if you divide by a number that keeps on increasing, then it's going to become 0, the whole number. Which means at infinity, right, sort of v infinity, if we could say, is going to be 10,000 over 5, which is 2,000. So the maximum number of people who can get infected is roughly 2,000. And it's an exponentially increasing, it's gonna go like that. I'm sure in 135 you talked about this particular method here, and it has a name, some endpoint behavior of functions. You try to see what happens as x goes to infinity and as x goes to negative infinity. So in this case, it sort of caps out at 2000. It cannot go beyond 2000, which is sort of why it works with these viruses is because after a certain point there are not enough people who can get infected. Okay, one last application of this is continuous compounding. When you have compute compound interest continuously, again this e makes an appearance, where amount after time t is given by p times e to the rt. That's the principal. You put in the rate of interest per year and the number of years. Simple example, $1,000 is invested. After 3 years, you want to see what you have. Rate is 12% per year, continuous compounding. 12% is 0.12, right? Because the sign percent, this means per cent, and cent means 100, which means divide by 100. So you gotta be careful not put 12 there, because if you say 12, then that's 1200%, which is crazy interest. Nobody's gonna give you that much. 0.120 times 3, right? Times 3 times 1000. So that's a pretty good deal, because in a year you get $1433.33 for doing nothing. Okay, so the important thing here is just make sure you convert this into the correct term, yeah, because it's percent. The 12 doesn't go in here. So if you put in 12 here, that's gonna become like 143,000. It's crazy. Okay, that's it. End of. I'm just calling it like. I'm not giving it day numbers for these videos. So this is week 5 video 2, and then maybe a couple more videos on logarithms.